Hello students. In this video we will be talking about chapter 2 and part 1 of the video series of chapter 2. There are two parts to this chapter. Since there are quite a few topics that I wanted to discuss in this chapter, I broke the chapter down into two parts and not have a huge chapter for you to go over. So in this chapter, we will be talking about the basic elements of C++. It is pretty much, quote unquote, your introduction to C++. And in this chapter, you will learn about the basic components of the C++ program, including the functions, the built-in functions, and the functions that you will be using in your programs, special symbols and identifiers. We will be looking at some simple data types that we can use in your program at this time. We will be looking at order of operations, how C++, in what order C++ does the operations. We're going to look at program expressions, especially arithmetic expressions. We're going to become familiar with string data types, and we're going to learn how to assign values to variables. We're going to learn how to declare variables, how to input data into memory using the input statements. We're going to become familiar with using increment and decrement operators to increment and decrement values of variables. We're going to learn about how to output information from the program. We're going to learn how to use the preprocessor directives and why they should be used. We're going to learn how to debug syntax errors, how to properly control our program, structure our program, and comment and document information about our program. Become familiar with compound statements, and also how to write a complete C++ program. So what is a computer program? A computer program is a sequence of statements whose task is to do something for us, whose job is to do something for us. It requires planning, and in the last video we talked about algorithm, which is a plan to write your program, and then you actually code your program. So it's like cooking. You got to plan. You just can't go to the kitchen and start cooking. You got to make sure, first of all, you have all the ingredients you need. You have to make sure you have all the tools you need, pots, pans, the different cookware that you need. And then once you have everything, then you need to have the recipe, which is the algorithm, and then you implement that recipe using the ingredients and the equipment, and then you start cooking. You don't just start cooking without planning. So similarly, writing a program is the same way. You got to plan it. You got to make sure you have the necessary tools. Then you have to have the algorithm, which is the recipe, and then you write code. Okay. So let's look at this program, a C++ program. This is how a typical C++ program looks like. It's just a small program. There's not much going on in here. So this is the program. As you can see, there are instructions there. I'll go over the parts of the program in a minute now, but you can see, the line, the instructions, the code. It's a one-page program. It has a few lines of instruction. And when you run that program, this is the output, right? So it'll tell you program to compute and output the perimeter and the area of a rectangle. And given the length and the width, our program calculates the perimeter and the area. So let's look at the program and identify the parts of the program, right? So you will notice that you have the program here. You have variables here. These are the variable declarations, right? In here, we declare our variables, and they are of the type double, right? And these are the names of the variables: length, width, area, and perimeter. These are the names of the variable. These are the types of the variable. In our case, in here, we're using the type double, right? And then C out is the output. You saw that output, right? This is the output we wanted, right? This is the output we want. This is the output line we wanted printed, right, onto the output. So that's what this is. C out will produce that line for us. And there's an end line, and don't forget the semicolon. All the statements in C++ ends with semicolon. Then we are assigning a value, right, a double value, 6.0, to the variable length, right? So now the variable length contains the value 6.0. Okay. Then we do the same thing here. Width is 4.0, right? As you can see, you have to enter values in double format, right? Then using those values, we calculate the perimeter, right? The perimeter is 2 times the length plus width, right? We don't have to put the values directly in there. We're using the values that are in these variables or containers, in layman's terms, to calculate the perimeter. And then we do the similar operation with area. Area is equal to length times width, right? So we're multiplying width with the length and assigning it to the variable area. And then after that, we do the output. We output length. This is the word because it's in quotes. It's a string, and this is the value of the variable. We're not going to show length. We're going to show what value is in there. You see the difference? The difference here is that this is a string. It's in quotes or double quotes, and this has no quotes, right? So the value of length will be outputted, and the end line, and we have a semicolon there. So we do the same thing for all these different statements. Here we are outputting length, width, perimeter, and area. And as you can see, that's what we did here: length, width, perimeter, area. Okay. So let's go ahead and move forward. Here I show you the variables. So when we create the variables, we are reserving an area of the memory for that variable. The variable is called length. It's in a different place of memory, right? And a reserved area of the memory is for that particular variable of that name. Okay, so we do that for all the different variables, the 4 variables that we're using in this program, or we use in this program. And then when you assign number 6 or the double 6 into the variable length, it gets stored in that variable container, right? So moving along, our C++ program contains, at least sometimes contains, subprograms or functions. What are functions? Functions are a collection of statements, a bunch of statements. When executed, they accomplish something, right? So it's like in cooking, you prepare some, you mix some ingredients and prepare a paste, maybe that you're going to use in your cooking. So you combine a bunch of ingredients to make a paste, right? That is used in your cooking to make that main dish. So subprograms are like that, or functions are like that. They are like small. They're a collection of steps that does something for you. Now these can be predefined. Now, which means you can buy paste, like Donna Maria's mole, right? And or they could be standard. There are some standard functions that can be utilized in your program design. Programming with a particular language has rules or syntax rules, right? Those are the rules that specify which statements are legal and valid and which ones are not. So you need to write all the statements in a legal manner. You cannot have a single statement with anything illegal in there or invalid in there. Otherwise, your program will not run, will not compile. So you got to make sure that your program is error-free. Semantic rules determine the meaning of the instructions. So it could be possible that you don't have any syntax errors, and then you can compile, but when you run the program, you have problems. Now, those are semantic problems. Those are semantic errors. So you got to make sure that you follow the semantic rules so that you don't have any problems in your program. So a programming language consists of a set of rules, symbols, and special words, and libraries, and a bunch of other stuff that you're going to learn later on. Okay? So comments are for the reader, not the compiler. Like two types. Single line begins with double slashes, forward slashes. And given the length and width of the rectangle, this C++ program computes and outputs the perimeter and area of a rectangle. All of that sentence is enclosed in a comment, and every line is a comment, right? In that particular area of the comments. You can also have multiple line comments by using forward slash and a star. Begin with the forward slash and a star, end with a star and forward slash. Okay, and then you can put as many lines as you want. You don't have to have two slashes at the beginning of each line. You just start with a slash and a star, and then you write as many lines as you want and end with a star and a forward slash, and they're all considered comments. Okay. Now there's something called special symbols in C++. But before we get to the special symbols, I want to define the word token, right? Token is a small individual unit of a program written in any language, So this is not a token is just a word, right, for a small unit of a program, and it could be written in any language, right? So what does C++ tokens contain? They may contain symbols, word symbols, and identifiers. We're going to learn about identifiers in a minute, but know that identifiers can be considered C++ tokens. So special symbols in C++, these are some of the special symbols in C++, plus, minus, star, forward slash, and so on and so forth. So these are the special symbols that C++ has. So C++ has reserved words just like any other language. The reserved words, you cannot redefine them within a program, and you cannot use them in your program for example, you cannot use a reserved word as a variable for yourself. You can't do that. They must be used for the intended purposes. For example, you cannot define you cannot define a variable called int because it's a reserved word. It's off limits. So what are the some of the different reserved words for data types? Int, float, double, character, constant, void, and return. So these are some of the reserved words. There are many reserved words, but I've listed some of them over here. Okay, and let's see. What else? Next, we have identifiers. What are the identifiers? Identifiers is a name of something that appears in a program, right? It consists of letters, digits, and the underscore character. It must begin with a letter or underscore. It cannot begin with a number. Okay, it cannot begin with a number. It cannot have spaces. It cannot have special symbols. It cannot have, star, asterisk, percentage sign, and you can have all of those things. It's best to only have letters and numbers and underscore for your identifiers. Okay, and C++ identifiers are case sensitive. So number with the capital letters is not the same as number with lowercase letters. So there are several predefined identifiers in C++. The common ones that you're going to learn right away is C out and C in, right? Those are the two predefined identifiers. So unlike reserved words, predefined identifiers may be redefined, but that's not the best practice. Don't do that. Okay, I wouldn't recommend you to do that. So here are the legal identifiers in C++. First, conversion, pay rate. As you notice, pay rate is a camel case. That means it's a combination of two words, and the second word starts with a capital letter. That's called the camel case. And the table also shows illegal identifiers. The first identifier has a space. The second identifier, hello, exclamation, has exclamation mark, which is illegal. 1 plus 2, you cannot have plus in your identifier. Second, which means you cannot begin with a number, right? So every C++ program contains white spaces, including blanks, tabs, and new line characters. White spaces separate special symbols, reserved words, and identifiers. So white spaces are important. You got to pay attention to your white spaces. Okay, don't overdo them, and don't skip them, because they lend themselves to not just readability but also your execution of the program. So proper utilization of white spaces is important. So pay attention to that. All right. Data types. So a data type is a set of values together with a set of allowed operations. What are the different data types? Integers are a data type. Floating numbers are data types. Double a data type. So, and then you have your own data type called enumeration. So there are different data types. You have simple data type, you have structured data type, and then you have pointers. So pointers are pretty unique to C and C++ that you're going to learn later on. Okay, so there are several categories of data types, but I'm going to be discussing the simple ones on this slide. They're integral or integers, floating points, and enumerations. Integers can further be characterized as characters, short, int, long, bool, unsigned character, unsigned short, unsigned integer, and unsigned long. Then there are floating numbers, which are decimal numbers, and they are 4 bytes in length, I believe. There are 4. And then enumeration, that's the user-defined data types. Okay. So here are some of the values and memory allocations for simple data types. Integers has 4 bytes, Boolean 1 byte, character is 1 byte, and long is 64 bytes. It's a pretty big range there, as you can see. Here's an example. Negative 6,728, 0, 78, plus 763. These are all examples of integer data type, right? They're positive. Integers do not require a plus, but a negative requires a minus, right? For negative integers. Booleans, there's two values, true or false. A variable of Boolean type can contain either true or false. That's it. Character can contain a single letter, digit, or special symbol, and it has to be in single quotes. So remember that rule. That's a syntax rule. Character in C++ must be enclosed in a single quote. Okay. You can also specify a blank character. Just put single quotes with a space in there. Okay. There you have it. So now, floating point data types. Here are the examples of floating point data types, right? So floats have a range, and they use 4 bytes to represent floats in C++. These are some of the examples. And here is double. Floating data types represent any real numbers. They contain 4 bytes. they use 4 bytes in memory, whereas double is double that, which is 8 bytes. So if you're going to use decimal numbers, I suggest you go with double, okay, so that you don't run out of space. So, but if you are very, very sure that your range is not going to exceed 10 to the power of 38, then go with float. But double is a safe way to set up the values. Okay. All right. So next, let's go ahead and look at the maximum number of significant digits, decimal places for float, which is 6 or 7. I would say, for sure 6. Maximum number of significant digits for double is 15. So as you can see, it doesn't hurt to go with double, right? So precision, float is single precision, double is double precision, right? So again, as you can see, the doubles are more precise, and so therefore I suggest you go with double. Every time you want to represent a decimal number, go with double. Here's the data type. The last topic of discussion in this part of the data type variables and assignment statements. To declare a variable, you must specify its data type. Some languages don't require that. They automatically, figure out what when the data is put into the variable, what type of variable that is. But C++ is different. You have to first specify the variable's data type and then put that data of that type into it. So what is the format? The format is you declare the data type and then the identifier, right? So an example: integer, counter. Integer is the data type, counter is the identifier. Double, interest rate. Character, grade. It could be A, B, C, D, or F, right? So assignment statement is a statement where you have a variable on the left side of the equation and an expression is on the right side of the equation. So example, interest rate is equal to 0.05. So that's your data types, variable, and assignment statements. All right, that concludes the part 1 of this chapter, and I will see you in part 2.